In this video, we're going to talk about what I would consider a little math hack called prime factorization. Prime factorization as a technique is useful through all of algebra, up through calculus. Generally speaking, what prime factorization allows you to do is take a number and to break it up into its essential components in terms of multiplication. To jump right into it, the idea of prime factorization is to take a number and write it as the factorization of primes. Primes, by the way, are numbers that can only be divided by 1 in itself. So example is 2, 3, 5, 7, 11, 13, and on the way up. So these are all numbers that can't be divided evenly by any number except for 1 in themselves. And then the idea of factorization just means to write as multiplication. And before we begin our first example, I just want to talk a little bit about what it means to factor and then be prime factored. So let's take a number. Let's use 24 in this case right here. There's a bunch of different ways to factor 24. One of my favorite ways is 4 times 6. Now again, this is the factored representation of 24 because I'm writing an expression that equals 24, but as multiplication. To write 24 in prime factored form, or the prime factorization, would be to write 24 as multiplication, but only using numbers from this prime list right here. And in this case, that would be 2 times 2 times 2 times 3. And maybe you can see the connection here between these two versions, and this kind of lends itself to one of the methods of writing the prime factorization. If we take this factored form right here, 4 times 6, you'll notice that 4 I've rewritten as 2 times 2, and then 6 I've written as 2 times 3. Generally speaking, the technique of prime factoring is take your number, factor it in any way, and then any of those numbers that can be factored again, keep on factoring them. So I've taken 24, written it as multiplication, then took my 4 and my 6 and wrote those as multiplication. If any of these numbers weren't prime, by the way, the word for numbers that aren't prime is composite. So another way to say it, if I had any composite numbers here, I would factor those also. You keep on doing that until you only have prime numbers. Finally, to say the cool way of writing this statement right here would actually be to say 2 to the third times 3 to make that all nice and compact for the prime factorization of 24. Okay, so let's introduce a technique for finding the prime factorization. Again, as previously described, one way is just to rewrite it as multiplication and keep breaking them up. But one beautiful way to keep things organized is what we call a factor tree. And so what I'm going to do is take our number 216 right here, and then I'm going to break off my multiplications before it. Generally speaking, when I do this, these two numbers need to multiply to be this number right here. It doesn't matter at all what type of multiplication I use, but my technique is always just to use prime numbers. And since I see this as an even number, the first thing I'm going to do in my calculator is take 216 and divide it by 2. I just did that and I found that it's 108. So I know that 216 is 2 times 108, and I'm going to keep going with this process. I can't break up 2, so I would branch off a 2 here, but 2 is a prime number. I circle my prime numbers. It helps me keep an eye on them right there. So 108, I'm going to write this as 2 times 54. Again, just dividing that by 2 to find 54. 2 is a prime number. Keep that one. Now 54. I can divide that by 2, and that is 2 times 27. And now my run with the 2's seems to have come to an end because I no longer have an even number. So I just jump it up to the next prime number. I'm going to see if I can divide. Oh yeah, I can definitely divide this by 3. 27 is 3 times 9. 3 is a prime number. 9 is composite. I can write 9 as 3 times 3. And you'll notice the whole game with this tree, this is the same way as just rewriting these multiplications over and over, but in this visual organized way. And I've stopped at any of these branches that have a prime number. If I didn't have a prime number, I just kept on breaking them up. The resulting prime factorization is just the ends of all these branches or all of those prime numbers multiplied together. So in this case right here, what I've just found is that 216 equals 2 times 2 times 2. So I got 3 2's here and then 3 3's. Nice. Then just to write this in the exponent form would say this is 2 to the third times 3 to the third. And just for fun, let's do one more example. I'll attack this a little bit differently, but with the same structure of this factorization tree. So I'm trying to find the prime factorization of 180. We'll start with 180. And again, I always say that I would divide this by 2 out the gates. But when I see a number like this, quite honestly, I would write it differently. I see this automatically as 18 times 10. And so that's what I'm going to write down here. And again, it doesn't matter what multiplication, as long as this branch multiplies to be the number above, we're all good. And each of these just becomes their own little branching here. So I'm going to look at 18. Right away, I see that as 2 times 9. I'm going to circle the 2 because that's a prime number. The 9 isn't, and I can break that up, but I'm going to come back to that in a second. 10 is 2 times 5. The 2 is a prime number. 5 is actually also a prime number, so I'll circle that. I'm done in all those branches. And my dear old friend 9 here can break into 3 times 3, both of which are prime numbers. And with all of that work right there, I've quickly found my prime factorization of 180, which is 2 times 2, or 2 squared, 3 times 3, or 3 squared, and then a 5. Last thoughts for you is that prime factorization is really useful if you know where to apply it throughout intermediate algebra and college algebra. Specifically, it's really useful when simplifying radical expressions, whenever you're working with fractions, finding least common denominators, greatest common factors. And generally speaking, anytime you're working with numbers in a context through which multiplication or division is the main operation, prime factorization can be super useful, speed up your process, let you do things without having a calculator, and help you limit mistakes.